Hi, hello everyone, my dear students, children, teachers, parents, and all the stakeholders. Heartily welcome to Class 8 Mathematics. This is yours, Konakiran Reddy. First of all, my sincere thanks to all of you for watching my videos. And here in this video, I am going to solve some exemplar problems from NCERT 8th class exemplar book. And my sincere thanks to NCERT for publishing such a great book. Now quickly let us go through the problems. These are the problems related to chapter 1, that is rational numbers. Here we have so many problems. In this video let us do some problems, and in the next upcoming videos let us solve the remaining problems also. Yeah, quickly let us start this one. Okay, right. In questions 1 to 25 there are 4 options, out of which one is correct. Choose the correct answer. So clearly these are multiple choice questions. Here we have, in each question we are given 4 options. Out of those 4 options only one answer is correct. We need to choose that one. First problem. A number which can be expressed as p by q, where p and q are integers and q is not equal to 0 is. Clearly we know that that is a rational number. The definition of rational number is a number which can be expressed in p by q form, where p and q are integers and q is not equal to 0. So clearly this is a rational number. Now let us go to the second problem. A number of the form p by q is said to be rational number if. Clearly rational number is in the form of p by q, where p and q are integers and q is not equal to 0. That is the definition of a rational number. We know that. So let us check the options. P and q are integers. Yes, that is correct. But q must not be equal to 0. B, option B is P and Q are integers and Q is not equal to 0. So option B is the correct answer for this one. Now let us go to the third problem. The numerical expression 3 by 8 plus negative 5 by 7 equal to negative 19 by 56 shows that. Here 3 by 8, this is a rational number, and negative 5 by 7 is also a rational number. If we add two rational numbers, what is that we got? Negative 19 by 56, this is also a rational number. So that means if we add two rational numbers, then we got another rational number as the result. Clearly, this is the property which shows rational numbers are closed under the operation addition. So this is nothing but closure property. So this property is closure property of rational numbers under the operation addition. So let us see options. A. Rational numbers are closed under addition. Yes, this is the correct option. Now let us go to the fourth one. Which of the following is not true? Okay, let us see the options. Rational numbers are closed under addition. So we know that rational numbers are closed under the operation addition. That means if we add two rational numbers, then we will get another rational number. So it is correct. So that is true, but we need to get which one is not true. So option A is not our answer. So B, rational numbers are closed under subtraction. If we subtract one rational number from another rational number, we will get another rational number. So let me take one example. Suppose if I take 1 by 2 minus 1 by 4, suppose if you subtract, actually you will get negative 1 by 2. So here 1 by 2 is a rational number and 1 by 4 is another rational number. Here negative 1 by 2 is also another rational number. So we can say that rational numbers are closed under subtraction also. So this is true, but we need to get which one is not true. So option B is also not our answer. Now let us go to option C. Rational numbers are closed under multiplication. Here also, if you multiply two rational numbers, we will get another rational number. So we can say that rational numbers are closed under multiplication also. So this is also not our answer. Now D. Rational numbers are closed under division. So that means if you divide a rational number by another rational number, we need to get the result is also a rational number. Actually, this is true for all the rational numbers except 0. So that means if you take a rational number like 4, divide this one by 0, what will you get? Division by 0 is not possible. Division by 0 is undefined. So that means 4 by 0 will not be a rational number. So we can say that rational numbers are not closed under division. So here we are given that rational numbers are closed under division. So this is not correct. So our option is this one. Right. Let us move on to next fifth problem. So let us see fifth problem. Negative 3 by 8 plus 1 by 7 equal to 1 by 7 plus negative 3 by 8. Suppose if you take this one as A and this one as B, then clearly this one is A and this one is B. So that means we can write this one as A plus B is equal to B plus A. What is this? This is nothing but commutative property of rational numbers under addition. So let us see which one is the correct option. Addition of rational numbers is commutative. Yes, this is the correct one. Right. So option A is correct in this case. Now let us move on to sixth problem. Which of the following expressions shows that rational numbers are associative under multiplication? First of all, what is associative property under multiplication? Suppose A, B, C are three rational numbers. Then A times B times C equal to A times B times C. This is what we say associative property under multiplication. Let us check whether option A is correct or not. So suppose if you take 2 by 3 as A, then negative 6 by 7 as B and 3 by 5 as C. Now it looks like, this one looks like 2 by 3 means A times negative 6 by 7 is B, 3 by 5 is C. Now let us see the right side value. 2 by 3 that is A times negative 6 by 7 that is B, then times 3 by 5 it is C. So exactly this is nothing but the associative property under multiplication. So option A is correct. Next seventh problem. 0 is, we know that 0 is the additive identity. That means there is an identity element for addition of rational numbers. Let us check. Option A, the identity for addition of rational numbers. Yes, that is correct. Now let us go to eighth one. 1 is, we know that 1 is the multiplicative identity of rational numbers. Let us see. Option A, the identity for addition for rational numbers. No, the identity for addition is 0, not 1, right? So let us see option B, the identity for subtraction of rational numbers. There is no such element. That means for subtraction, there is no identity. So 1 is not the identity of subtraction. Now let us see the identity for multiplication of rational numbers. So this is the correct option. We know that 1 is the multiplicative identity in rational numbers, right? Now let us go to ninth problem. The additive inverse of negative 7 by 19 is, suppose if you take A, for this the additive inverse is negative A, and if you take negative A, the additive inverse is A. So here negative 7 by 19 is our number. The additive inverse of that number will be 7 by 19. Simply change the sign of number. That's it. That will be the additive inverse. So 7 by 19 is the correct option. So let us move on to next problem, that is 10th problem. Multiplicative inverse of a negative rational number is, suppose if we take a negative rational number, suppose let us take negative 2 by 3. What is the multiplicative inverse of this one? That is also called as a reciprocal. How can you get reciprocal or multiplicative inverse of any number? Just switch the numerator and denominator. That means write numerator as denominator and denominator as numerator. So here negative 2 by 3 we have, the multiplicative inverse will be, what is that? Negative 3 by 2. This is the multiplicative inverse of negative 2 by 3. So here if you take a negative rational number, the multiplicative inverse is also a negative rational number. So the option in this case is option B, a negative rational number, right? Suppose in this case we have, instead of multiplicative inverse, suppose we have additive inverse. So additive inverse of a negative rational number. Suppose the question is like that, then what will be the answer? That is what we need to think about. Let us take same example like negative 2 by 3. For negative 2 by 3, the additive inverse will be positive 2 by 3. So for a negative rational number, the additive inverse will be a positive rational number. Okay. Right, let us go to 11th problem. If x plus 0 equal to 0 plus x equal to x, which is rational number, then 0 is called. In this case, this is nothing but the definition of additive identity. So then 0 is called additive identity in rational numbers. Okay. So here let us see option A. Identity for addition of rational numbers. Yes, option A is correct one. Let us move on to next problem, that is 12th problem. 12th problem. To get the product 1, we should multiply 8 by 21 by dash. So we have the given number 8 by 21. It is to be multiplied by some number. The result must be equal to how much? That is equal to 1. To get 1 as the answer, 8 by 21 is to be multiplied by which number? So we need to take the reciprocal of 8 by 21. That's it. So if we take 8 by 21, the reciprocal of 8 by 21 is, what is that? 21 by 8. Simply switch the numerator and denominator. That means write numerator as denominator and denominator as numerator. Now you can see 21 and 21 gets cancelled, 8 and 8 gets cancelled. That will be equal to how much? 1. So the answer is 21 by 8. Option C is correct. Now let us move on to next problem, that is 13th problem. 13th problem. Minus of minus x is same as minus of minus x is equal to, we know that minus times minus is plus. So this will be plus x, or simply we can write that one as x. So option B is correct. Now let us see 14th problem. The multiplicative inverse of negative 1 by 7 is. Before answering this question, let us write negative 1 by 7. This is a mixed fraction. Now let us convert this into improper fraction. We know that 7 times 1 is 7 plus 1. So that is 8. So negative 8 by 7. So the multiplicative inverse of negative 8 by 7 is negative. Switch the numerator and denominator. That means 8 by 7 we have. Write this one as 7 by 8. So this negative 7 by 8, this is the multiplicative inverse of negative 1 by 7. So what is the correct answer? We have option D. So option D is the correct answer. Be sure negative 7 by 8, negative 7 by 8, 7 by negative 8, all are equal. Be sure. We can use negative anywhere, whether in the numerator or in the denominator or to the entire fraction. Right. So option D is the correct one in this case. Now let us go to 15th problem. If x be any rational number, then x plus 0 is equal to, we know that, suppose in the place of x we have 4. So then 4 plus 0 equal to how much? 4. Suppose we have 5 here, 5 plus 0 is 5. So in general, if you write x plus 0, that will be equal to how much? X again. So option A is correct. Now let us move on to 16th problem. The reciprocal of 1 is. Reciprocal means we need to switch numerator into denominator and denominator into numerator. So for 1, suppose if you take 1, we can write this one as 1 by 1. The reciprocal is also equal to how much? 1 by 1, and that is equal to 1. So the reciprocal of 1 is again 1. So option A is correct. Now 17th one. The reciprocal of negative 1 is. For negative 1, the reciprocal is also equal to negative 1. So option B is correct. Now 18th problem. The reciprocal of 0 is. Reciprocal of 0. Suppose if we take 0, 0 can be written as 0 by 1 or 0 by 2 or 0 by 3, like that. For this, the reciprocal will be, for 0 by 1, the reciprocal is 1 by 0. But 1 by 0 is an undefined value. Why? Because division by 0 is not possible. So that is undefined value. So the reciprocal of 0 is not defined. So that is option D is correct in this case. Now let us move on to 19th problem. The reciprocal of any rational number p by q where p and q are integers and q is not equal to 0 is. Simply here we have reciprocal of p by q. We know that reciprocal of p by q is nothing but q by p. So option D is correct. Now let us move on to 20th problem. If y be the reciprocal of rational number x, then reciprocal of y will be. So there is nothing but x. So reciprocal of a rational number x, that means 1 by x. Reciprocal of a rational number x, that is equal to 1 by x. And that is equal to how much? That is given that one as y. Now, if you multiply both sides by x, what will we get? 1 by x times x equal to y times x. So x and x gets cancelled. So we can write 1 equal to y times x. Now the reciprocal of y means nothing but 1 by y. So divide both sides by y. So 1 by y equal to yx by y. So y and y gets cancelled. So 1 by y equal to x. Instead of doing all these things, if you take any number, if a is the reciprocal of b, then b is also reciprocal of a. That's it. Now let us move on to 21st problem. The reciprocal of negative 3 by 8 times negative 7 by 13 is. Before going to answer this question, let us simplify this product. So here minus 3 by 8 times minus 7 by 13 we have. Minus times minus is plus. So we will get a positive number. Now 3 times 7, that is nothing but 21. Divided by 8 times 13. 8 times 13 is how much? 104. So 21 by 104. That is the correct option. Where is that? Let us check. So C is the correct option. Now let us move on to next 22nd problem. Which of the following is an example of distributive property of multiplication over addition for rational numbers? First of all, what is distributive property of multiplication over addition? If we take A, B, C, these are three rational numbers, then distributive property of multiplication is A times B plus C equal to A times B, that means first multiply these two, then multiply these two, that means plus A times C. This is what we say distributive property. Now let us check in the options which is similar to this distributive property. Now first one, let us take A, negative 1 by 4, let us take this one as A, 2 by 3 as B, then this is C. It looks like A times B plus C. So we can write A times B plus C, that is left side value, and right side value let us check. Negative 1 by 4 is A, so A times 2 by 3 means B. Okay, then plus negative 1 by 4, again we have A times negative 4 by 7 is C, so A times C. Now clearly this is nothing but distributive property. So option A is correct. Let's move on to next problem. So 23rd problem. Between two given rational numbers we can find. Between any two rational numbers there will be infinite number of rational numbers. You take any two rational numbers. Between those two we have infinitely many rational numbers. So option D is correct. Option A, one and only one rational number. No, this is not correct. Only two rational numbers. No, this is also not correct. Only 10 rational numbers. This is also not correct. There will be infinitely many rational numbers between given two rational numbers. Okay. Next 24th problem. X plus y all over 2 is a rational number. Let us see the options. Between x and y, less than x and y both, greater than x and y both, less than x but greater than y. Now let us check. To answer this question, let us recall the mean method. What is that? Mean method. What is mean method? This method is used to find out a rational number between two rational numbers. Suppose if you take A and B are two rational numbers, then according to mean method, A plus B all over 2. This is the rational number which is in between A and B. So we can say that x plus y all over 2 is a rational number between x and y. So that is the correct answer. Now let us move on to next problem. 25th problem. Which of the following statements is always true? Let us take first A. x minus y all over 2 is a rational number between x and y. Actually, this is not correct. Let me give you one example. Suppose if we take x equal to 1 and y equal to 2, let us take. So then x minus y by 2 means that will be 1 minus 2 all over 2, which is equal to negative 1 by 2. You see, this negative 1 by 2 is not in between 1 and 2. So option A is not correct. Now let us go to option B. X plus y by 2 is a rational number between x and y. In the previous question, we discussed about this one. X plus y all over 2 is a rational number between x and y. So this is the correct one. Now, for curiosity, let us see whether C and D are correct or not. Of course, we know that, but let us see. X times y by 2. Suppose if I take x equal to 1 and y equal to 2. Then x times y means 1 times 2 divided by 2. 2 gets cancelled. This is equal to 1. Now, check this 1 is in between 1 and 2. No, it is not. This option is also not correct. Option D, x divided by y all over 2 is a rational number between x and y. Of course, we can take 1 and 2 as the example for this one. But for a simple calculation, let us take x equal to 4 and y equal to 2. So then x divided by y means 4 divided by 2 all over 2. So this is equal to 4 divided by 2 means 2. So 2 by 2. 2 by 2 equal to how much? 1. So 1 is not in between x and y. So option D is also not correct. Okay children, in this class we finished 25 multiple choice questions. Next we have fill in the blanks questions. Let us do fill in the blanks question in our next video. Thanks for watching. If you like my explanation, please press like button and share, comment, and before that, don't forget to subscribe my channel. This is your Konakiran Reddy. Thank you. Thanks for watching.